In this video, we are going to learn how to solve problems involving sound wave in physics. And after going through this video, we'll be able to solve basic calculations involving sound wave in physics easily. So, in short, stay to the end of this video because I'm going to explain some issues here. I'm going to simplify a lot. Okay, having known that, let's begin with these questions I have here and progress from there. Okay, question 1 says, a hunter at a distance x from a cliff fires a gun. He hears the echo from the cliff after 2.4 seconds. If the speed of sound in air is 340 meters per second, calculate x. Alright, now let's take note of this formula for calculating sound in air. Alright, sound wave in air. Use the formula velocity. We have it to be v equals 2 times distance over t, where t is our time, our x is our distance. So from this question, let's bring out our parameters. So the question, we have our v to be 340 meters per second, and we have our t to be 2.4 seconds. So we don't have our x, we're looking for distance. So all you have to do now is to impute these parameters in this formula to get your x. So when you do it, you're going to have 340 equals, so we have 2 times x over, okay, our time is 2.4, so it cross multiply. When you do this, you're going to have 340 times 2.4 equals 2x. So when you simplify further, you're going to have, let me clean this side. Okay, so you're going to have 340 times 2.4, let me punch it. So it's going to give us 816, okay, equals 2x. So to make x the subject formula, divide both sides by 2. So this 2 carry this 2 here. So 816 divided by 2, so it's going to give us 408. So since we are looking for x distance, the unit will be meter. Alright, so this will be the answer for question 1. So let's wipe this now, solve for question 2. Very interesting, guys. Okay, question 2 says, a sound wave emitted from the bottom of a ship travels at 1,500 meters per second vertically downwards through water to an ocean bed 1,000 meters below and is reflected upwards. What is the time interval between the instant the sound is emitted and the instant the echo is received? So we're looking for time. Remember, we are still working with this formula, v equals 2 times distance over t. So in this question, let's bring out the parameters. We have our v to be 1,500 meters per second, and we have the distance x to be 1,000 meters. We now have the time. Alright, so we're looking for time is unknown. So let's impute these parameters in this formula. So when you do it, you're going to have our v is 1,500, okay, equals 2 times 1,000, alright, over t. Okay, so when you cross multiply, you're going to have 1,500 t equals, so 2 times 1,000 equals 2,000. So to make t the solid formula, divide by both sides by 1,500. So this we cancel this, therefore our t will be, this cancel this 0, this 0 cancel this 0, so we'll be left with 20 divided by 15. So what we divide first, we have 5 can divide, 5 divide 20, we have it to be 4 over 5 divide 15, 3. So this will be our answer. Is either you leave it in this form, in fraction, or you break it down. When you break it down further, you're going to have 1.33. Let's leave it at 2 decimal places, seconds. Alright, so this will be the answer. Either of it will work. So that's for question 2. Now let's write below and solve for question 3 before we go to the next question. Okay, so question 3 says, a man standing 99 meters from the foot of a turkey leaf claps his hands and hears an echo 0.6 seconds later. Calculate the velocity of sound in air in meter per second. Okay, so we are still working with this basic formula. Okay, we are still working with V equals 2x over t. Alright, so let's begin our parameters from this question. In this question, we have the x distance to be 99 meter, and we have our t time to be 0.6 seconds. So we don't have the v, is no looking for v. So let's impute this parameter in this formula. So when you do, you're going to have v equals 2 times 99 over, so we have the time to be 0.6. So when you simplify this, you're going to have, let me punch it my calculator. Okay, so 2 times 99 will give us 198 over 0.6. Okay, so 198 divides 0.6 is going to give us 330 meter per second, and this will be the velocity of sound in air. Alright, so let's wipe this and solve further questions on sound wave. Let's wipe this page. Okay, so let's look at question 4. I have here question 4 says calculate the frequency of fundamental of a closed pipe of length 20 cm if the speed of sound waves in air is 340 meters per second. Alright, now note this, guys, very important. For frequency of sound wave in a closed pipe, alright, is calculated using frequency equals velocity over 4 times length of sound wave in a closed pipe. Alright, whereas for frequency of sound wave in an open pipe is calculated using frequency equals velocity over 2 times length of sound wave in the open pipe. Alright, whereas when you want to calculate length of sound wave in a closed pipe, you use this formula: length equals wavelength, that lambda, over 4. Whereas in an open pipe, you use this formula: length equals wavelength over 2. Alright, so take note of these basic formulas, alright, for it, for closed pipe and for open pipe. So with this, let's solve question 4. So question 4, let's get our parameters. We have our length to be 20 cm. Now, you have to convert this cm to meter, alright, to standard units. So to do that, you divide by 100. So it will be 20 over 100. Alright, so when you divide 20 by 100, you're going to have 0.2 meters. Alright, so let's plug it in this formula. Remember, we have the velocity to be 340 meters per second. Okay, so let's plug it in this formula since we are dealing with a closed pipe. So frequency will be 340 over 4 times 0.2. Okay, so let me punch everything in my calculator and see what it's going to give me. So I have it to be 425 Hz. So that's the unit of frequency, Hz. Okay, so that's for question 4. Now let's wipe this and solve question 5, and after it you can call it a class. Okay, so for question 5, it says the resonating air column of a tube closed at one end emits its fundamental frequency when the effective length of the tube is 55 cm. Calculate the frequency of vibrating air column if the speed of sound in air is 330 meters per second. Okay, so let's get the parameters. In this question, we have the speed of sound, v, velocity to be 330 meters per second, and we have the length to be 55 cm, So you convert it to meter. To do that, you divide by 100. So when you divide this by 100, it's going to give you 0.55. Alright, so we're going to have 0.55 meter. Okay, so let's impute the parameters in the formula. Remember, this is a closed pipe, so we are still going to work with this formula. So it's going to be frequency. We are looking for frequency. Okay, equals the velocity is what, 330 over, so we have 4 times length is 0.55. So let me punch everything in my calculator and see what it is going to give us. Okay, so it's going to give us 150 hence. This will be the answer. Alright, so this is basically how you can solve problems involving sound wave in physics. This is basically calculations on sound wave in physics. Hope you learned something interesting from this video. If you are new to the channel and you have not yet subscribed, short hit the subscribe button now to subscribe to the channel for more videos like this. Also like, share and comment on this video to tell me how you feel for what I learned from this class. If you seem to have any specific questions to ask, feel free to leave your question in the comment section below and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching.